Right, this question is quite wordy, so you need to read it carefully. A car passes a point P at 12 meters per second. Its motion over the next 60 seconds is modelled as follows. The car's speed increases uniformly from 12 meters per second to 36 meters per second over the first 15 seconds. Its speed then increases uniformly to 48 meters per second over the next 25 seconds. The car maintains the speed for a further 30 seconds, at which point it reaches Q. Sketch a speed time graph to represent this motion. Calculate the distance P to Q. When it reaches the point Q, the car is brought uniformly to rest in T seconds. The total distance from P is now 2,970 meters. Calculate the value of T. Okay, so drawing the graph. So the first bit is to draw a set of axes. It's only a sketch, so it's not an accurate plot. So draw a set of axes and label your axes. Right, in the first 15 seconds, at the initial thing, it starts at 12. So it starts from here, and then in 15 seconds, it goes to 36. Then it increases uniformly over the next 25 seconds. So 25 plus 15 is 40. So it goes from 36 to 48 there. And then in the next 20 seconds, so it takes it to 60, it will get to there, which is Q. The distance travelled is given by the area underneath this graph here. So if we split it up into trapeziums, so we've got two trapeziums and a rectangle. So the area of a trapezium is going to be that length plus that length times the vertical height divided by 2. So in this case, it's going to be 12 plus 36 times the height, which is 15, divided by 2, which gives me 360 meters. Here, this next one is going to be 36 plus 48 times 25 divided by 2, which gives me 1,050 meters. This is just a rectangle, so this is just going to be 48 times 20, which gives me 960 meters. So the distance will be 360 plus 1,050 plus 960, and if we add those together, we get 2,370 meters. Right, carrying on. Right, when it reaches the point Q, the car is brought uniformly to rest in T seconds. The total distance from P is 2,970 meters. Calculate the value of T. Right, so there's our graph so far. And we know the total distance is 2,370, but then it's brought uniformly to rest to this point R, which I'm going to call R. And we know that the distance from we've got to find the distance QR. That's going to be the total distance of that, which we were told is 2,970, minus our distance for this bit here, which is 2,370, which means it's 600. Right, we know the area of this triangle must be 600, so we've got to find the value of T, how long it takes for the particle to come to rest. So half times base, which is T, times the height, which is 48, must be equal to 600. 24T must be equal to 600. T will be equal to 25 seconds. Okay, so the time will take to come to rest will be 25 seconds. Okay, this has been a video to show you how to sketch a speed time graph and then use it to find some times and the distance travelled. I hope you've understood, and I thank you very much for watching.